Welcome to this video. Welcome to Grateful Learner. My name is Deepak Kumar. I am the founder of Greatful Learner in Civil Engineering. Today is our topic is remote sensing and its role and its principle and GPS ग्लोबल पोजिशनिंग सिस्टम। GPS के बारे में हम लोगों ने सुना होगा। इस वीडियो में हम डिटेल में पढ़ेंगे कि GPS का क्या रोल होता है, रिमोट सेंसिंग का क्या रोल होता है, रिमोट सेंसिंग कैसे काम करता है, रिमोट सेंसिंग कैसे सोलर को अट्रैक्ट करके लाइक जो भी वो सारा मैकेनिज्म होता है वो डिटेल में हम इस वीडियो में पढ़ेंगे। तो पढ़ते हैं डिटेल में GPS और रिमोट सेंसिंग के बारे में। टाइप्स ऑफ रिमोट सेंसिंग भी पढ़ेंगे इस वीडियो में। मेजरली ये पार्ट्स है सॉइल मैकेनिक्स का। तो चलिए डिस्कस करते हैं दोनों को और पढ़ते हैं डिटेल में।
So today our topic is remote sensing and GPS. GPS means global positioning system. Okay, so first of all we discuss detail by detail in this presentation video what is remote sensing, the usage of remote sensing, and the GPS and the usage of GPS and the which types of GPS and the its application of GPS and the application of remote sensing also. Okay, so first of all we know what is remote sensing. Like remote sensing is a sensing which science of or acquiring information about the earth surface without actually contacting with it. Remote sensing is the science of acquiring information about the earth surfaces without without being correct with it. This is done by the sensing which recording reflected by emitted energy and processing, analyzing and applying that information. Remote sensing basically work that this processing, main work is processing, analyzing and applying that information, remote sensing. Okay, now the next one is this is the process of remote sensing is the fundamental. We have see here this is solar. Okay, this is solar, and this is the observation, and this is the like social network which have occupied, and the process will be done. This is the sun and the process will done, and we have see here in this presentation video. Okay, now the basic principle of remote sensing, the basic principle of remote sensing is like most remote sensing system utilize the sun's energy which travel through the atmosphere are selectively scattered, observed depending upon the composition of the atmosphere and wavelength involved. Basically the principle of remote sensing is the consumption of the wavelength, its wavelength and the involvement mean, and this radiation reach earth interacts with the object, some of the this radiation observed, reflected, emitted and other the sensor recorded and processed in the form of image which then analyzed to extract information about the objects. The second principle of remote sensing is the with the objects interacts between the absorbed and reflected. Absorbed, which have terms we have used in this slide, like emitted from the like bonded and or the surface. This is the information and all about the basic principle of the like remote sensing. Okay, now the prolongation for various atmospheric reflective index condition, that the sub reflection and the normal and the super reaction, then the tracking we have the wave and the flow and the observation in discussing the flow. Okay, now one's terms is electromagnetic energy. So first of all we know electromagnetic energy. What is electromagnetic energy? Electromagnetic is the describe the all different kinds of energy, the different kinds of energy released into a space such as stress as the sun, and these kinds of energy such as radio waves, then TV waves, then as radius waves, then the heat infrared, then light, then ultraviolet, the X-rays, the microwaves, the gamma rays. These are the types of electromagnetic energy. These are the electromagnetic energy. There are types of the electromagnetic energy. Now the next one slide I will discuss. Discuss is the like electromagnetic spectrum. So these are the rays: gamma rays, X-ray, ultraviolet, intraviolet, microwave, and radio. These are the configuration, and the waves will be high energy to flow the lower energy. The peak as the visible at the ultraviolet. So it means electromagnetic shapes, and it means visible range of ultraviolet will be provided in remote sensing. Okay, now the types of the sensor. Now the types of the sensor, with two types of sensor. First one is optical sensor, then the microwave sensor. Then what is optical sensor? It was developed for NIR remote sensing. Then the thermal infrared remote sensing. The microwave sensor define active sensor, then the passive sensor. These are the types of the sensor, and also discuss these two types and its variation. And the active now the active sensors we have discussed in this slide. Active sensor provide their own energy and illumination of the target, directing a burst radiation at the target. And use sensor and the basically from to the target. Adjective sensor provide the capability to obtain measurements anytime regardless of the time of day and the seasons, and they can be used for examining energy types. They are not sufficiently provided by the sun, such as microwaves, or to better control the weight is target to illuminated. These are the active sensors. Now the next one is sensors like sensor detection. Sensor measures level of energy that are naturally emitted, reflected, or transmitted by the target object. Then the passive sensors are those which detects and the acquiring energy, and the radioactive energy is the sun, and the reflected and solar energy, for example, can only proceed when target is illuminated by the sun, thus limiting visible light sensor or illuminator from being used during a nighttime pass. These are the thermatic power, and the primary sensor on the Landsat satellites is a good example of the passive sensor. Uh, like Landsat satellites are the good example of passive sensor. Now the application of remote sensing in civil engineering. Okay, the various civil engineering application in areas included in remote sensing. Okay, the first one is urban and regional planning, the site investigation, terrain mapping analysis, the water resources engineering, the town planning and urban infrastructure development. Also, then the transportation network analysis, then the land analysis. These are the applications which do have with the help of remote sensing. These are the applications of remote sensing to use in civil engineering. Okay, now the regional planning at and site investigation with the help of remote sensing. The site investigation in general required topographic and geologic consideration. Remote sensing data permits such as assessments. In case of dam, site investigation information on topography is essential. Good geological consideration involves the different soil and the rock types of physical parts of the property. These are the regional planning and site investigation of remote sensing with the help of remote sensing. Okay, now in the selected river crossing and the pipelines, these are the considered which are such as slopes include river banks, terrace, and the valley wall. History of rivers erosion and the sedimentation would give clues needed for locating the sites where so-called likely to occur. High capital. These are the hydrogeological and geomorphologic information along the geologic structure in the water was in the selective water cooling and pipelines with the help of remote sensing and to work through do you have the train mapping and assessment of what the performance of the train for a specific development, and that can be made through the evaluation for this train information required for the RS data by generating by the digital train model. Now advantages of remote sensing. This is the very important. Provides a view for the large region. First advantage is offers georeference information and digital information. The next one is most of the remote sensors operates in every season, every day, every time, and even in real tough weather. Easy acquisition of data or data over intelligible areas. A single data can be used for different uses. These are the advantages of remote sensing. Okay, now the next one is we have discussed in this slide, like GPS. Okay, GPS. What is GPS? The global positioning system. It is satellite based on radio navigation system for determination of a precise positioning and the time using radio signals from satellites in real time or in past post processing devices mode. The navigation satellite timing and ragging global positioning systems and the developed by the US Department of Defense, and the permits with the suitable receivers to establish their position, speed and time on land, sea or in the air at any time of day or night and in the weather condition. These are the like what is GPS and the use of GPS and the benefits of usage and the where preference to use the GPS. Okay, now GPS system we have considered and we have understood GPS system. Okay, the GPS system, the space segments consist of constellation of 24 satellites and departing the Earth at altitude 20,200 kilometers. These satellites act as reference points from which receivers on the ground determine their position. The control segments consist five stations here on the Earth, which the satellites. The user segments consist antennas, receiver, processor. These are the GPS system. These are the three major segment: space control and user of GPS. Okay, now the how does GPS work? How does GPS work? GPS. These are the satellites and the three signals we have distance covered on the Earth. These are the distances. Distance is 20,200 kilometer. Then the GPS receiver use the principle of ranking. The receiver measures the distance from a location on the position of several satellites to determine the latitude and the longitude of the position on the Earth. Thus the GPS works. Okay, now the application of GPS. Here the application of GPS providing a control geographic photography. The second one is photogrammetry. It is the science of making measurements from photographs, especially for the recovering the exact position of surface points. And the first one is finding out location of offshore drilling the pipeline power line. The next one, the next one is navigation of civilian ships and planes. These are the application of GPS. Okay, now the next one is GNSS, Global Navigation Satellite System. There are four GNSS on the external players. These are GPS, then the GLONASS, then the Galileo, and the Compass. Then the Global Positioning System is also called Navstar GPS, navigational system with time and tracking, operated by the United States of government. The second one is like Global Navigation Satellite System, GLONASS, operated by the Russian government. Then the Galileo Navigation Satellite System to be operated by the European Union. Now the Compass Navigation Satellite System to be operated by the Chinese government. These are the global navigation satellite system which are what provided all over the world and the operates of GPS. Okay, now thank you so much.
आई होप ये वीडियो आपको अच्छा लगा होगा। इस वीडियो से आपको बहुत अच्छे हेल्प मिले होंगे। तो इस वीडियो को लाइक करें, शेयर करें एंड सब्सक्राइब करें और एक अच्छा सा कमेंट करें। धन्यवाद।